short lecture on what we saw today. What happened in the PT bottle? To explain this, I wrote down the chemical equation right here in words without using chemical formulas or structures. So, oh, by the way, the formal chemical name of baking soda is sodium bicarbonate or sodium hydrogen carbonate, but in this video we call it baking soda. Okay, so baking soda reacted with citric acid to give carbon dioxide, water, and sodium citrate. Carbon dioxide that was formed inflated the orange balloon. Some of the carbon dioxide remained in water to give carbonated water. And water and sodium citrate remained in water and they were colorless, so you didn't notice them. Okay, moving on to a deeper understanding of the chemical reaction. Here I wrote down the chemical equation using chemical formulas. This is baking soda. This is citric acid. It has a bulky branching structure. This is carbon dioxide, water, sodium citrate. At this point, this equation might seem to be essentially the same as the equation in words that I showed you on the previous slide. But one of the advantages of using chemical formulas and chemical equations is that you can get quantitative information from it. Let me show you how to do that. What I need to do first is to balance the chemical equation so that the numbers of all atoms on the left-hand side are the same as the right-hand side by placing the right numbers or coefficients in front of these chemical formulas. In this particular case, placing 3 for these formulas gives the balanced equation. Now you know the quantitative information between baking soda and citric acid. This equation tells you 3 moles of baking soda react with 1 mole of citric acid. This quantitative relationship is one crucial piece of information in determining how much baking soda and citric acid you need for this experiment. Next, I'm going to talk about why I used the particular amounts in the demonstration. 28 grams of baking soda and 21 grams of citric acid. To answer this question, we need to do some calculation. The calculation is divided into 2 steps. The first step is to determine how much carbon dioxide you want to produce. And then based on the amount of carbon dioxide, calculate the amount of baking soda and citric acid you need. Let's do the calculation. This is the famous ideal gas law. PV equals nRT. V is the volume of the balloon, or the amount of carbon dioxide you need. I looked up on the internet that the particular balloon holds about 7 liters. I want a little more to take into account gas leak, so I chose 7.5 liter. P is atmospheric pressure in Pascal, temperature is 273 Kelvin, gas constant R, you don't need to calculate, you just look it up on the internet or in a book. The amount of baking soda is unknown. What you need to do next is to rearrange the equation so that you can solve for n. All you need to do is to plug these numbers from the previous page into this equation, and then you get this number, 0.33 mole. That means you need 0.33 mole of baking soda. Now you know the amount of baking soda in mole. You want to convert this number to grams and get the atomic mass of each atom involved from the periodic table to get the molecular weight of the baking soda. And do the conversion by using the molecular weight like this. And finally, you get 28 grams of baking soda. For citric acid, according to the chemical equation, ratio baking soda to citric acid in mole is 3:1. So mole of citric acid is 1/3 of that of baking soda, which is 0.11 mole. Convert this number in mole to gram using the molecular weight of citric acid. And finally, you get 21 grams of citric acid. Hope you enjoyed my video. I'm looking forward to seeing you next time. Thanks for watching.